Howdy, it's Mr. Rao again, and we're going to be continuing our conversation about rational and irrational numbers. In our last video, we gave some examples of rational numbers, and remember, those are just simply numbers that can be written as a fraction or as a ratio of the integers p over q when q cannot equal 0 because you can't divide by 0. And today we're going to look at some irrational numbers as well and give some examples of those. And really, those kind of fall into three categories. We have some famous constants, some famous numbers in math that we may be familiar with that are irrational. And the most famous of those are obviously pi and then Euler's number, which is denoted by e. But we also have imperfect squares. And an imperfect square is really just any square root that doesn't work out evenly. So for example, we talked last video about the square root of 25. The square root of 25 has an actual pure number, that makes this true. 5 is the square root of 25 because 5 times itself is 25. So that's called a perfect square. But irrational numbers are imperfect squares. So the square root of 17, for example. There's no number when multiplied by itself that'll equal 17. But it's not just kind of odd prime numbers that are imperfect. Even something that we might not think of, like the square root of 24, is also an imperfect square because there's no number times itself that'll equal 24. And this is the realm where we start to understand how there's millions and, truly infinitely more irrational numbers than rational numbers in the world. Because for every perfect square, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. We also have numbers in between here. So in between 9 and 16, I'd have the square root of 10, the square root of 11, the square root of 12, the square root of 13, the square root of 14, and the square root of 15. And as the numbers grow, these gaps become larger and larger, and we have more and more numbers in between. So we have infinitely more irrational numbers because all of these are imperfect squares. The square root of 9 is a perfect square, and therefore that would be rational, just like the square root of 16 and the square root of 25. But all of the numbers in between 16 and 25, we would have 17 and 18 and the square root of 19 and so on. So we have infinitely more irrational numbers. So that's kind of the second category. We have famous constants, and pi and e are the most famous of those. We just spoke about the imperfect squares, but we also have decimals that never terminate and never repeat. We talked about terminating decimals. Those are decimals that just end in zeros, or repeating decimals, decimals where we see a repetitive pattern. But there's some decimals that just don't do that. If I were to write 0.487164, that's a 4, 3, 2, on and on and on, I don't see any pattern there. It's obviously infinite, so it's not terminating and it doesn't repeat. So decimals like that would also be irrational. So those are really the three main categories of irrational numbers.